Hello everyone, my name is Tej and today we will be looking at the selection sort algorithm, which is another sorting technique. So as the name suggests, selection sort scans the complete array first and selects the minimum element that it can find, and then it finally swaps it with the first position. So as you can see in this array, it will first scan the complete array, find the minimum element. So here we can see that 1 is the minimum element. Then it will swap it with 5 as it is the first position. So 1 will come in the first position. Then it will scan the rest of the remaining array. So 4, 1, 4, 5, 3, 2 now. So 2 is the most minimum. So it will swap with 4. So 1 and 2 are now in their correct positions as we are sorting in ascending order. Similarly can be done with other elements. So we can imagine it like this, that there are two parts of the array, unsorted part and sorted part. So first of all, 5, 4, 1, 3, 2. First of all, the complete array is unsorted. Okay, so after the first iteration, it will scan 1 as the most minimum element and swap it with the position of 5. So the new array will be 1, 4, 5, 3, 2. Now this part is sorted and this is the unsorted part. Okay, so now the for loop will run to the complete unsorted part and find the minimum element, that is 2, and swap it with 4. So the new array will be 1, 2, 5, 3 and 4. So now this is the sorted part and this is the unsorted part. Okay, so now 5, 3 and 4 will be checked. So the most minimum element is 3, then it will be swapped with this position right here. So the new array will be 1, 2, 3, 5, 4. Similarly, now this is the sorted part and this is the unsorted part. So this unsorted part will now be checked, and as you can see 4 is less than 5, so 4 will be swapped with 5, and the new array we will get is 1, 2, 3, 4, 5. That is the complete sorted array. We only have to run this for loop n-1 times, as you can see that when we did 1, 2, 3, 4 came in the correct position, 5 automatically came in the correct position. So we can just remove the unnecessary things to make it more time efficient. So coming to the pseudocode for this question. Okay, so first we will initialize the array 5, 4, 1, 3, 2. N is the length. Okay, then we will start an outer for loop first, starting from I equals to 0 till n-1. As we said, n-1 iterations are required. Then inside the outer for loop, we will initialize a min element variable that will be set to I in the beginning, and this will store only the index. Okay, so index only, and not the value that is currently in that index, only the index. This will make the swapping easier in the future. So now the inner for loop will go from j equals to I plus 1, that is the next element of I. So for the first iteration, if I is equals to 5, the j loop will go from 4, 1, 3, 2 and so on. Okay, till the complete array, till n. Okay, now we will check if array element j is less than array min element. So we will say that have we found an element inside the array that is less than the current min element, and if j is less than min element, we will set the min element to j. So now we have the in the end, that when the complete array is scanned, this will be the index of the element that is of the most least value. So after the first iteration, j would be equal to 2, as the index for 1 is 2. Okay, now when we get out of the inner for loop, we will just swap the values. So the swapping part is done here outside the inner for loop. So swap array I and array min element. So as you can remember that in the bubble sort algorithm, we were swapping in every iteration, and in every step we were trying to swap at least adjacent values at some point. In every point we were trying to swap something. In this, we first find the minimum value and then in the end we swap. So comparatively, there are a little less swappings done in selection sort. So after the swapping is done and the outer for loop is closed, in the end we can just print the array. So this is the selection sort algorithm. If you want a little less swappings, you can use selection sort. If you are okay with more number of swappings, you can use bubble sort. So this uses O(n) squared time. So now I will show you the code of this selection sort algorithm. So coming to the code for the selection sort algorithm, we have first initialized the array as 5, 4, 1, 3, 2, the same as we took in the pseudocode. N is the length of the array. So now we will start the outer for loop from I equals to 0 till I less than n minus 1. Okay, and we will now initialize the min element variable that will store the index of the most minimum element in that iteration. So min L equals to I, as I'll just put a comment here saying that index only. Okay, so now the inner for loop will go from j equals to I plus 1 till j less than n. That is the complete array. It will traverse through the complete array. Okay, so now we will check that if array element j is less than array element min element. That is the min element. So if it is true, then we will set min element equals to j. So min element has now been updated. So now coming out of the inner for loop, we will swap the value of array element j, array element I with array element min L. So the normal swapping method, array I equals to array min L, L equals to 10. Okay. So the swapping has been done, and in the end, we can just print the array equals to 0. So after printing the array, we will say the complete array has been sorted. So let me just run this. So as you can see, the complete array has now been sorted 1, 2, 3, 4, 5. So this was the code for the selection sort algorithm. Thank you for watching.